Thank you. Hello, everybody. My name is Qian. I'm from Bloomberg. This work was done during my PhD at the Group Lens, University of Minnesota. So these are my collaborators, Martijn from Highlevel University of Technology, Gediminas from Carson School Management, Max and Joe, my advisor from Group Lens, University of Minnesota. Okay, so most prior recommender system research focused on learning from user action feedback. But this work is different. We will take a look at the user inaction. So what does it mean? Here's the research platform we used, Willemsen. Willemsen is a live movie information site where users can browse movie information and interact with movie information in various different ways, as you see here. So then they can get personalized movie recommendations, as you see, topics. This is the page title. What we ask, however, is not about those acted upon items. We ask, what about the other items that users did not interact with them? What can we say after we observe that we show these recommendations to the user, but we didn't see any actions from the user? So what are the potential reasons why a user to skip them? Okay, before I answer that question, first we ask this question. Why does it matter? Why does inaction matters? I will illustrate with two examples, one from Amazon, another one from YouTube. Hope this is fun. Okay, how many of you have seen these recommendations right in front of your face? Okay. How many of you have seen this again and again? Right? So obviously, it depends on how many times it takes for Amazon to take the hint. Okay, it's enough. Maybe the system would be better to show something else. Now, let's look at YouTube. These are recommendations for me. They are pretty good. So, okay, the reason why they're good, I mostly use YouTube with my daughter. So she's fascinated about the Peppa Pig. So the first one, that's really good. So my daughter asked to watch that Peppa Pig. But I hope her to explore it a bit, so I recommend her to watch Moana. She actually likes Moana, but not so much compared with Peppa Pig. So we negotiated. At the end, we decided to watch both, okay? So we first go to Peppa Pig, and we watch Peppa Pig for a few stories. Then we come back to the homepage. And it completely changed the recommendation. Where's my Moana? So as you see from these examples, failing to correctly interpret user inaction or just ignore them can create user frustration or confusion, negatively affecting user experience. So now question becomes, how do we interpret user inaction? We conducted a field survey. We asked movie-lens users. We randomly pick one inaction item and ask users. This is when we collected the data, and this is the amount of data we collected. This is the result, what we found. We found 7 categories of user inaction reasons, okay? The biggest category, user did not notice. That's 40% of the cases user did not notice. Then for 15% of the cases, user noticed, but they have watched it before, previous consumption. If the user noticed and they have not watched it yet, then 6% of the cases, the preference estimation is wrong. They will not enjoy it. For example, maybe the Amazon case. 9% of the cases, users think others are better. This is computation effects from the items that are displayed together with the inaction item. 18% of the cases, users think recommendations are okay, but not now. The context is not right, maybe in future. 7% of the cases, users plan to explore it soon in the next few pages. And 6% of the cases, users have decided to watch it. So they have made the decision, although, remember, this is an inaction item. They didn't do nothing. They did nothing on that item. So for example, the YouTube case. Okay, what do we do with it, with this understanding? We further ask this question. Should we continue recommending with the options, 3 options, rather not, maybe, or definitely? This is what we found. We found 5 levels of significant different levels of future recommendation preferences, from the highest, most preferred to the least preferred. The first level preference, decide to watch or explore later. Next level, others better or no now. They are not different from each other. The third level, not noticed. Fourth level, this is better than the fourth level, watched. Then the last level, would not enjoy. So what this basically means is that the future recommendation strategy, how we do with it, that those in-action items depends on how we interpret user in-action. Okay. If it's decided to watch or explore later, for example, the YouTube case, we should definitely keep recommending in the next page views, or for example. And if it's would not enjoy, then we'd better stop recommending. But in practice, we don't know. We can't ask users all the time, so we need automatic models or classification models to tell us. We build one. These are all the predictors we use, from item attributes, display factors, user activities. We also build sub-models to estimate the user ratings and action probabilities. This is the best models classification accuracy we get, 48%. This is significantly better compared with the majority class not noticed, 40% around, but it's not a great classifier. It's a hard task to infer user in-action reasons. We found some interesting predictor effects. For example, we can estimate the rating probability, how likely this user is going to rate it. And from this, if this estimated probability is higher, then it's more likely that the in-action reason is watched, they have consumed before. Similarly, we can estimate the wish listing probability, the probability that the user is going to add that item into a wish list. If that probability is higher, then it's more likely the reason for inaction is decided to watch. These are pretty intuitive effects we found. What can we do? Can we still improve recommender systems, utilize this user in-action model? Okay. So we can't directly utilize the in-action class because the classifier is not great. So we turn to this second approach, utilizing the inferred 7 class probabilities. We tried 3 different perspectives to improve recommendation, preference estimation, in other words, rating prediction. Our experiment doesn't support this. The second approach, action prediction and recommendation timing, they are supported. But for the purpose of this talk, I'm going to focus on the second one, action prediction. The task is, given a user and item pair, we want to estimate what is the item's probability of engaging the user or not. This could be used for re-ranking recommender system. This is a frequent question we ask while building recommender system. So in order to utilize that in-action model, we first ask, was this shown to the user before? Was there a previous page view associated with this item? Then if the answer is yes, we further ask, was this the in-action item? If the answer is yes, then we ask our in-action model, tell me the 7 class in-action probabilities, and I'm going to utilize this information. This is experiment. You can see that in the control condition, no input from the predicted probability. It's standard matrix factorization with user ID and item ID as the input. In the experimental condition, we have introduced the additional predicted probabilities. We see improvement in UC. It's not a big jump, but it's substantial enough to make an impact in real systems. Now, these are the high-level messages from this study. We found that there is important information in user in-action feedback. We want to do more research on this, and that can significantly affect our future recommendation strategies. Specifically, we have 7 categories of user in-action reasons, and 5 levels of significantly different future recommendation preferences. Yes, and remember that if it's definitely decide to watch or explore later, then definitely keep recommending, but if it's not enjoy, and then we should stop recommending. And predicted user action probability can be used to infer the reasons of user inaction. This is interesting. Similar in different systems, you might be able to estimate your user's probability of engaging with the system in various different ways, then potentially utilize that to infer the user inaction reasons. Last message, we have initial evidence suggesting that if we model user inaction, that can help with recommendation, for example, action prediction. I want to say thanks to GroupLens for supporting my PhD. I recently graduated, and also the graduate school, University of Minnesota. I also want to thank Bloomberg for supporting my traveling here. And with that, I conclude my talk. Thank you.
Hi, Munya Lalmas, Spotify, London. I really like this work. No click, what is the meaning of it? Something that maybe you have done, did you account for so you have a set of recommendations, did you account for the location within the thing? So for it's kind of a nearby of what has been clicked, it may have a particular meaning, and if it's further down, maybe your model, I don't know.
Right. Yes, I think, yeah, that's counted as one potential feature for infer user inaction.
And was it a significant one, or?
I mean, how we operationalize that feature, maybe specifically? So I think what you're referring to is whether we utilize the information that if there is an action on the page that can affect our inference about the inaction for other items. For example,
Yes.
if it's very close to that action item, then potentially that, because of the proximity, that user pay attention to that.
Yes.
I think, yes. So this is also related to my previous work that is about a gaze prediction, eye tracking. So we found that, yes, this type of feature indeed help. It can tell you, it has significant effects in predicting that whether this user actually noticed that item. For example, this is one possible class of the 7 categories.
Thank you.
Right.
Any others before I steal the mic again? No, so I have a very specific question for you.
Oh, cool.
Here. You were saying about wish list probabilities. Could you give us, it's a very detailed question, but could you give us a bit of a hint what actually informs the wish list probabilities? You said this is indication that they've decided to watch it later. So what is that probability based on?
Wish listing. Okay. In this specific case, we built a standard matrix factorization model. So we look at all the historical wish listing behavior from the users. So you have it's an implicit feedback. You can build an implicit feedback model from that. In other words, just use user ID, item ID. So it's a standard collaborative filtering algorithm, right? I guess I think it's possible to introduce more to improve the submodels. But the current modeling dependency is already fairly complex. I think it should be interesting to further look at as well.
So from the global profile or from wish list behavior only?
The model is trained based on all the historic data from all the users, right?
Gotcha. Right. Thank you for the very nice presentation.
Thank you.
Yeah.